All right. What we're going to do is I'm going to prepare you or give you a little tutorial on how to practice SynthDefs. It's just a good idea if we're learning about SynthDefs to just make a bunch of them, I would say. I'm going to give you actually a template to use, but I'm going to recommend that you retype it every time just to give you some practice. This will become soon second nature if you're using Super Collider a lot. And the way to have a facility and ease with this is to just do it a lot and to do it, often. If you do a little bit, just like practicing an instrument. If I've, am away from Super Collider for a while, it takes a while to sort of remind myself what things are and where things belong. So if you're going to use it intensely now for a little while, just as a little practice. Okay, so what we're going to do is we're just going to make a bunch of SynthDefs. Let's say recommend making 5 to 10 or something like that, and just repeating them over and over again, just getting the hang of it. Little template. Okay, and so SynthDef is capital SYNDEF to get the SynthDef. Sorry, to get the SynthDef object, and all objects have that little scope, the parentheses. Now SynthDef, if you put a comma in there, it looks for these arguments. It's really the first two that we're interested in. Oh, I forgot. And then it just needs this tag.add. We're going to add that SynthDef to the server. That sends it to the server. It's stored there, and then we can use it anytime during our session. So let's have let's name it. Let's just call it Siny. Okay. Because I'm just going to make this a sine tone. And then there is the function, which is where all our sound is going to happen. So if we just do 2 curly brackets, all our functions have that sort of syntax of 2 curly brackets there. All right. So that's the basic structure. That's how we're going to make a SynthDef, and mostly just fill in that function there. I'm going to give it a couple lines there. And so this is generally how I start with this structure there. Okay, that's your blank slate, except for the name. Now, the first function, the first thing I generally put in is the out. This is the thing that connects your synthesis or whatever your process, the thing you made, your little synth, to the speakers. It sends the sound out to your sound card. So OUT dot AR, okay, again, the parentheses for the scope, and out looks for 2 arguments. Bus, that's the channel it's going out. Generally, I'm just, for now, we can make that a variable eventually, but for now, we're just going to send it out to our left speaker, R0, our left channel, and then whatever you're sending out. Now, I'm just going to give it a variable here, and then we'll just change that variable for all of our different SynthDefs. So I'm just going to call that one syn. Now, as you hopefully recall, our first line usually in a SynthDef will be an arguments. So we're going to just args, and then theirs will be the next one. So we're just going to create lines for that. And then we're going to add our synvar to that. Okay. So there you go. We've created an way to get sound out. We've created just the ability to make arguments and variables. Now let's define our syn as a sine wave oscillator. So I'm going to use the UGen sine os, capital SINOSC. And you notice all UGens start with a capital letter, and oftentimes if it's another word within that, it's also capitalized. I'm going to do AR because it's going to be an audio rate. And then it has it's looking for these arguments, okay? And really the one main one I'm going to be concerned with in this case is frequency. So I'm just going to make a variable, FREQ, or it's going to eventually become an argument, and put that in there. So it's going to generate a sine wave with this variable freq. So let's make that an argument, and let's give it a preset value, say 300 to begin with. And there we go. So that's already going to make sound. Now the next thing I like to put into our template is an amplitude, so we can change the volume. That's simply making an argument, AMP. And remember, arguments can be changed from the outside. Varies are for within the SynthDef to create simplicity and cleanness and clarity. But arguments are things that you're going to want to change. It's kind of like patching. You're going to want to change the pitch. You're going to want to change the volume. So amp, I'm going to just set that as a default 0.85. And also in Super Collider, you need this leading 0, otherwise it'll balk at you. Okay, so and then we're going to use that amp by multiplying the signal by the amp. So a signal is generating generally at least a sine wave, generating the signal very rapidly between -1 and 1, or 0 to 1, back to 0 to -1, back to 0. And then if you imagine that being multiplied by amplitude, so 1 times 0.85 will be 0.85 of its intensity, so it'll be a little quieter, times 0 will be nothing, it'll be 0. Okay, so that's why the simple multiplication works. Okay, so essentially we have most of what we need. So the main guts of it is this very simple structure you see here, and this already makes sound. Now I'm just going to add one more bit, which can actually add like double the amount of complexity of this, but it's useful to have the envelope, and we've done it before. So let's add an env to our variable, and we're going to make this equal. And remember, the envelope has two parts. env gen is to generate the envelope. It's the actual ugen. Okay, and usually it takes a bunch of these arguments, but we really are interested in the first one, the definition of the envelope, which we'll get to, and then a gate that's engaging the envelope and taking it away. Okay, so let's start with the envelope. Now we use the SuperCollider has a number of these built-in shapes, which is really nice. Otherwise, you can custom define your own envelope, which we won't get into right now. But in the mouse theremin example, we were using the ASR, which is what they call a sustained shape. So that's very useful for things like what we're doing with a mouse, where you have a push and a release mouse button, or if you're using like a MIDI keyboard where you push it to engage the sound, and as long as you're pushing that key down, you want that sound to sustain, and then when you release it, then you want the release envelope to take part. So that was this ASR that we used, and ADSR is essentially the same. It just gives you one more dimension of control. So you had to use this gate argument and send it a gate of 1 to attack it, and it'll just hold that pitch at the sustained level for until you give it a gate 0, and then it'll release it. So that's kind of like hitting the key and then releasing the key. In this case, though, I think it'll be handier, since we're just going to use code. I'm going to show you how to use code to start these sounds and stop these sounds. It'll be handier really to have a fixed shape that sustains for a fixed amount of time and then releases it on its own. So you just give it one command, it'll attack it, it'll sustain it, and then it'll release. So these are the standard envelopes. And we're going to use one that's just a linear one. We're going to use one called linen, L-I-N-E-N, okay, E-N. All right. And then if I put that parentheses there, it'll show the arguments, which are very similar. Attack, but instead of sustained level, now we have a sustained time. So it's going to sustain for that amount of time at that level. Okay, so we're going to do ATK, and then we're going to have a sustain, S-U-S, that's the time, and then a release. Now, I don't need to put level, and you notice one as an aside here, you notice when I put in arguments, I put them in order, and this corresponds to that. So I can call that whatever I want. I can call this curve, but it's still going to be the attack time, all right? But say I don't want to actually put in something for every argument here. Say there's a whole list of arguments, and I would just want to skip over a couple. Well, you can do that by just using the argument name. So I'm going to skip level here. Normally, whatever I put in here, no matter what I call it, it's going to be the level. But I want to actually use a curve. So if I want to skip that level, I'm going to type in the name of the argument, C-U-R-V-E, and then a colon. And you notice it's skipped over there already. So it recognizes that I'm defining the curve now. So I'm going to make a variable called curve, C-R-V. Okay. And then finally, so that's our shape. And it's going to attack, sustain for a certain amount of time, and then release. And then I'm going to have a gate. Now, the thing about this gate is if I just use a standard gate, if I just put, as I normally would do, gate, and then I make that argument up here, gate, you'd have to do gate 0, gate 1 to start it, and then you have to reset it to gate 0, and then you have to do gate 1 again. And that can be a little bit cumbersome. So we're going to use this special type of, just like those control rate arguments I showed you, there's another special type of argument that is a trigger rate argument, and that's delineated by using that symbol slash and then the letter T, and then underscore whatever you want. So we're going to call it gate. Okay, so now this time, whatever I send it, if I send it a 1 every time, it's going to re-engage that envelope and then let it sustain and then release it. So I don't have to go 0 again and then 1 and then 0 again and then 1. Okay, and then it's a control rate still, with the first argument being the default. We'll make that off at first, 0, and then the second being a lag. We don't need any lag right there. Okay, and so then that's us done with our envelope. And like I said, that was probably the most complex part of our code. But now we have a basic template now to use. Oh, the last thing we have to do, which I always forget, is to, well, a couple things actually. I've forgotten a couple things, is to use the envelope, env. We have to multiply our signal not only by the amplitude, but also by the envelope. And then also to add our arguments. I forgot to do that, and some defaults. So ATK might be 0.01, sustain. We might want a default sustain of 0.5 half a second, release time of 0.1, and then a curve. Now we have to be a little careful of minus signs. So equals minus is an actual thing. That combination is an actual thing in SuperCollider. So I'm just going to make sure I put, every time I use a negative sign for things, I'm going to put a little space there so it knows that that's connected to the number. So let's do -2 for the curve. Okay. Now we don't remember from our control rate arguments, we don't have to actually put this up here into the arguments. By just doing this tgate kr, it understands that that's an argument, and I can just pass it. It'll pass it automatically. All right, so I think we're ready to go. If I boot that, okay, and then I add my SynthDef to the thing, and then I create a synth. This is a equals synth.
Which for Yonkers has been a long time coming.
I started one of my movies, so I'll shut that off now. Okay, so synth, that wasn't the way my synth sounds. So synth, and then we give it the name, S-I-N-E-Y, Siny. So if we just start that, it doesn't make any sound because remember, our gate is at 0. So it's times the 0 envelope. So we just have to remedy that 8.set, and then we say the argument name, which is the gate. So we have to do the whole thing, T gate. Okay, not the KR bit. And then we're just going to make that 1. Okay, and notice how I just hit it once, and then it sustained for half a second, and then it released itself, huh? And then you notice I didn't have to go gate 0 every time. I just do that every time. Okay, well, that's great. So this is our template for creating SynthDefs. And really the only thing you'll need to change, at least for now, just for practice, is to change this bit here. Just find a different UGen to put in its place. And then, depending on the UGen you choose, the other bit you'll have to change is the arguments that correspond to that UGen. So in this case, it's just frequency. And most ones probably will have a frequency, but other ones might have other arguments that you would want to put in there. But I would recommend keeping everything else the same and just giving this a practice. But I would also recommend that every time you do it, you retype everything just so you familiarize yourself with the syntax and the steps to go. Okay, so let's go ahead and do that. I'll do a quickie one to show you, another way of changing, of creating, just creating a different type of sounding SynthDef. So SYNTH, I'm going to use SynthDef, and I'm going to create a thing, and then my name is going to be Blippy, because I'm going to use a blip, and then I've gotten my open my function, and then it's going to close and dot add. Okay, and then I'll get a little 2 spaces there for my function. I'm going to create an out, and then I'm going to send it out 0, my left channel, and I'm going to create a variable SYN to send it out to. I'm going to create a ARG space, and then a variable space, and then create my syn variable, and then I'll actually define it. My syn is going to equal to this. Now, instead of sign os, I'm going to use this blip.ar. Okay, and it has a number of arguments, but I'm just going to use the first 2, frequency and number of harmonics. And harms. Okay, we'll do that. Now, of course, you can look at that by doing Command D, and you can look at, and it tells you what these are about, and it describes the generator. Now, to find these different ones, a good one, if you do a search for tour of UGens, that's a good one, and it'll give you, these oscillators. I just recommend trying these ones: impulse saw, sync saw, clang, these type of things. Table oscillators, if you want, or noise generators as well. You get some different types of noise. Now, filters and stuff, those get a little bit different. You need a source and stuff. Maybe we won't get into those right now. You're welcome to try if you can, manage your way around it. So I'm going to use this blip one. Another way to do it is to go to, let's see, browse, and then go to UGens, and then maybe something like signals generators there. And they have a number of these sort of generators: blip, saw, Gauss, sine grain, sync saw, vibrato. Interesting ones. And you can granular, chaotic, all these single value. So yeah, it's worth looking at, just changing those. Okay, so I'm going to use the blip one, and so I have this frequency, and then I'll give it a default, say 300. I have number of harmonics, HARMS, and the default for them was 200, so we'll just keep that there. Okay, and the next step really is to add that amplitude, change the volume, and then we're going to make it equal to 0.85, and we're going to multiply our signal by the amplitude. Okay, and then we'll add our envelope. So ENV, and we're going to have an envelope equals envgen.ar, and the envelope shape will be that linen, env.linen, and we're going to have the attack, ATK, sustain, SUS, the release, REL, and the curve, which we have to spell out because we're skipping one. Okay, and then our trigger rate argument, T underscore gate dot KR, and we'll have a default of 0 and a lag time of 0. And that ends our envelope generator. All right, and then we have to add our arguments in here with defaults. ATK equals, and you can change these, of course, 0.01 for each thing if you want. So maybe we'll make a slower one for this one. 0.7, maybe 70 milliseconds. A sustain of 0.8, make that a little longer. Oh, SUS 0.8, and then a release time equals maybe a quick release then, 0.01, and then a curve of maybe -4, something like that. All right, so that's following that and retyped. Didn't take me that long. Another one there. Blip. Oh, oopsie. I made it all disappear. That's no good. Blip, add that. Oopsie. Okay, so I did something bad. It doesn't like this because I don't know why. Did I mess something up? Okay, here. I just didn't see my control rate. I have an N in parentheses, but I didn't put the N to the envelope generator. So we'll do that. Okay, and then now also remember we have, I used A here for my variable. And remember, all single letters are variables, but also you can use a tilde, so we might as well start that convention. S2 maybe equals a synth, and it's going to be this blippy. Okay, and I can engage it with arguments in place, or I can just use the set command to set the various arguments. But I'll show you more of that next time. Okay, I realized I didn't multiply it by the envelope, so the envelope's there. It's being used. I mean, it's being started and everything. It's just not being used here. So the signal is being multiplied by the envelope here. If it's not, then it's just sitting there. So when the envelope is 0, the signal is 0. When the envelope is 1, the signal is at its normal level. Okay, so then we're going to resend that SynthDef, and we're going to make one now no sound, right? Because it's multiplied by the envelope. And we can engage the envelope by doing s2.set and use the T underscore gate to 1. And you'll see here what I mean by the underscore. Well, you saw earlier. Okay. Now, I can also set something, I mean, I can go on, but this will be the topic. I'll give you a little teaser, a topic of the next tutorial. I can set various parameters. So, like, if I want to make a really long attack, 0.5 maybe. Oops. So, ATK is 0.5. Let's do that. And then the next time I hit it, and then maybe I can make the curve a little bit more dramatic. So I'm not sure if it's negative or positive direction I want to go into, but oops. But we'll try CRV, maybe -6, see what happens. No, I think it's the positive direction I want it to go to. If I want a real like that, yeah. And then finally, maybe, so it sounds a little bit backwards, we'll make the sustain a little shorter. 0. Right now it's at 8, 0.3 maybe. And of course, you can also change the various things, like number of harmonics, harms. And we'll change that to, what was it, 200? Let's see what happens when we say more than double it. That sounds very similar. Maybe we go the opposite direction. Take a look. Doesn't seem to change very much, huh? How about 1? Oh, there, that changes a big difference. To 10. All right, well, there you go. Okay, well, this is going to be more what we do with the next. I'll have my 5 UGens, SynthDefs, and then we'll play around with how you can just use code and create some sounds. So let me wrap that up. Just in review there, we're going to make a bunch of different SynthDefs, and this is really just a practice doing different SynthDefs. And I've made a couple here for you, but I would recommend you making 5 or 6 or 7 or 10 or something like that. Just whip them out, give them a try, and just get used to the syntax and what things you need to change. You'll get quite familiar with it. Again, I would just recommend retyping it, even though it seems a bit monotonous. That's the way you're kind of, I don't know if it's really physical memory, but you'll get yourself a familiarity. So when you see things, you recognize what they do, where they belong. Okay, well, good luck with that.